Have you ever wanted to control your Arduino projects with just the press of a button? In this lesson, we're stepping into the world of input and output modules, starting with one of the simplest but most powerful, the push button. You'll learn how to use buttons to control LEDs, buzzers, and other components. And we will update the ultrasonic alarm we built in lesson 6 to make it smarter, with a manual reset feature that gives you full control over how the system behaves. Sounds good? So let's get started. If you take a closer look at your Mind Plus Arduino coding kit, you will spot a small yellow module with a button on it. Go ahead and grab it. You'll be using it in this lesson. This isn't just any button, it's called a push button. What makes it special is that its internal contacts only touch when you press it. As soon as you release the button, the contacts separate and the circuit is opened. So when you press the button, the contacts close and electricity flows through. Release it and the flow stops. Simple enough, right? Now, how do we actually use this button with Arduino? If you've followed along with the previous lessons, you may be thinking, we just connect it to a digital port set as input, and you are almost right. But if you try that, just setting the port to input and connecting the button, you'll probably notice something odd. The port might randomly switch between high and low even when you are not touching the button. Weird, right? This happens because of electrical noise or electromagnetic interference from the board itself. Basically, without a clear signal, the input floats and picks up random voltage changes. To fix this, we need a resistor that forces the port into a non-state, either high or low, when the button isn't being pressed. This is called a pull-up or pull-down resistor. When the button is pressed, it forces the opposite state. In our case, since we are using a crystal button module and can't easily add an external resistor, we will set up the Arduino built-in pull-up resistor. That means the input pin will naturally read high, but when we press the button, it changes to low. This way we can reliably detect when the button is pressed. And in our example, we will use that button press to reboot the alarm system. If this is your first time watching this series, you might be wondering where I got all these components. They are actually part of the Mind Plus Arduino coding kit, a complete starter kit designed to help beginners dive into the world of Arduino. It comes with a wide range of components, sensors, cables, modules, an Arduino Uno, an LCD screen, and more. You'll be using every single item in this kit throughout the 24 lessons in this course. My kit was generously provided by GF Robot, the sponsor of this series. If you haven't heard of them, GF Robot is one of the leading companies in open source hardware. Their online store is packed with high quality components and kits. Not just this one, but many others as well. And the best part, they ship worldwide through a network of trust partners. So if you are planning your next STEAM project, I highly recommend checking out GF Robot. You'll likely find exactly what you need. Thanks again to GF Robot for sponsoring this video and helping make STEAM education more accessible to everyone. Today's project is basically the same one of the last class, but with a difference. You connect a button to port 7. If you didn't watch lesson 6, don't worry. Here is the list of materials we were using, and here is the diagram, so you know exactly how to connect everything. Now let's take a look at the code. As you can see, it's the sketch of lesson 6 with some changes. By the way, this script is available on the GitHub repository of this series. Link is in the description. To make our alarm system smarter, we've added a push button to pin 7 of the Arduino board. This button gives the user the ability to manually reset the alarm while it's active. Inside the setup function, we've configured this pin using input pull-up. This tells the Arduino to use its internal pull-up resistor, so we don't need to add an external one. When the button is not pressed, it reads high. When the button is pressed, it reads low. Now let's look at how the alarm works. When an object gets closer than 10 centimeters, the trigger alarm function activates. It starts blinking the LEDs and sounding the buzzer for up to 30 seconds. But here's the key part. During those 30 seconds, the Arduino continuously checks if the user has pressed the button. If the button is pressed at any time during the alarm, the loop immediately breaks and the alarm turns off. If the user doesn't press the button, the alarm will stop automatically after 30 seconds. In both cases, after the alarm ends, the system turns off all LEDs and the buzzer, and resumes monitoring again. This creates a responsive system where the user can quickly silence the alarm if needed, without waiting for the full 30 seconds. Now let's upload the code and see it working. This is the end of lesson 7. So what did we learn today? You built your first project that uses both input and output modules working together. You learned how push buttons work, how to read their signals, and how pull-up resistors help make those readings stable. And most importantly, you learn how to create more interactive systems. You use this knowledge to create more complex projects later. In the next lesson, we will learn about the serial monitor, an important tool for debugging and a topic every maker should understand.